Today, we will be demonstrating Newton's laws of motion. Without further ado, here's Miss Cronkleton giving us the first law.
Newton's first law, the law of inertia. Lazy law. Objects are lazy. An object at rest stays at rest, and an object in motion stays in motion unless a force, like friction or a push, acts on it.
Let's show you some demonstrations. First, we have objects at rest. Mr. Johnson is at rest until a force is applied to him, and now he is in motion. Let's watch that one more time. That was pretty satisfying. Boom! Got him. Second, you're going to see an object in motion wants to stay in motion unless acted on by an unequal force, which is Mr. Johnson being a force on me, stopping me. And lastly, you're going to see me running in a straight line until a force is applied on the side by Mr. Johnson, therefore changing my direction.
Newton's second law, force and acceleration. Heavier objects, more mass, need more force to speed up or accelerate. Lighter objects need less force. For example, it's much easier to push Mr. Reinhardt than it is to push Mr. Johnson.
Now you're going to see Mr. Reminder is going to try to push us with the same amount of force. So if the force is the same, why am I going so much further back than Mr. Johnson? That's because the more mass an object has, the more force is required to make it accelerate at the same pace. Here's another example to help us think about Newton's second law. All right, let's watch this again.
2, 1.
But let's go ahead and pause it and zoom in a little bit. Let's watch this one last time, but this time let's talk about it. Now, because Mr. Johnson has more mass, when he ran at me with the same speed, his force was larger. Newton's second law also means that more mass equals more force.
Newton's third law. For every action, there is an equal and opposite reaction. Whenever you push something, it pushes back just as hard in the opposite direction.
All right, Mr. Reinhardt.
All right, let's pause and talk about this before I do it. I am going to be applying a large force to the wall, but because of Newton's third law, the wall will also be applying an equal force directly back onto me.
Oh, shoot!
Now hold up. Let's pause this and back it up.
All right, Mr. Reinhardt, it's all you.
Oh, shoot!
Now, in case you didn't see it that time, I'm going to slow it down and show you one more time. My toe ends up slamming into the wall, which brings us back to Newton's first law. An object in motion wants to stay in motion, and my foot wanted to stay in motion going towards the wall until it was acted upon by the wall.